Alright guys, welcome back to another review video. This time we are going way back, um, figuratively and literally speaking, to something we covered at the beginning of the school year, and it's literally the beginning of our universe. Now, I'm not even gonna lie to you guys, I said it in class and I still mean it to this day. These are the standards I like the least because I feel as though they are unfair and extremely vague. And you will probably notice or will notice that they don't ask a lot of questions about these standards, and I think that's to an extent they're so vague they haven't exactly clarified what they're trying to test with them. One we're going to focus on first with Earth's place in the universe is 8.ESS1.1. And it is research, analyze, and communicate that the universe began with a period of a rapid expansion using evidence from the motion of galaxies and the composition of stars. What does that even mean? Well, they're pretty much trying to make you explain the beginning of the universe, or the Big Bang. And even real scientists can't do that. They have lots and lots of ideas, hypotheses, theories on it, but they can't agree on one being the correct answer. And it's going to kind of be impossible to do that because it happened a long time ago and no one was around to witness it. So there's a ton of math that goes into the science of trying to figure out what on earth happened then. Let's go back and look at the PowerPoint and some pictures to try to help break this down just a little bit. We'll focus on the universe beginning with a period of rapid expansion part, with motion from galaxies and composition of stars as evidence. Okay, so in order to understand the Big Bang Theory, we kind of have to go back to a little bit of chemistry and understand what our universe is made up of. And that's going to be matter, is what we focus on primarily. Matter is made up of atoms. Atoms are made up of protons, neutrons, and electrons. And those are made up of even smaller subatomic particles called quarks. And those are going to be kind of a focus here with the Big Bang. Hopefully this image gives you a little bit of a visual representation of what the Big Bang was. It's not an explosion at all. It's just the name for whatever instant, moment, action, series of events, phenomena happened that started everything. And yes, I know this can get touchy with some people, religious-wise or lack of religious-wise. Regardless of where you fall on that spectrum, you're kind of still trying to figure out the answer to the same question. If you go way on one end of the spectrum and look at it from a strong Christianity standpoint, you say God spoke everything into being. This is how it happened. Well, okay, your belief, you've correctly quoted your belief in that. What we're trying to do from a sciencey part is figure out what happened to the atoms and the matter when he spoke that into being. If you take it from just a strictly stripped down scientific part, you're still trying to figure out what happened to the matter and the atoms that generated and started everything. So please understand, I am not trying to say that your beliefs are invalid, and I'm not trying to pick one side over the other. I'm just trying to present you the information and the questions we have and tie it to this standard, but I digress. Let's get into this. So over here, this is going to be pretty much where the Big Bang begins. This is going to be your starting of time kind of point. This is the instant that Big Bang happens. And if you look down here, this is in milliseconds. So this is already very small. This is 10 to the negative 32nd milliseconds. Okay, that's what I mean when I say instantaneous. A blink of the eye is probably slow compared to that. Okay, moving on after whatever triggered the Big Bang happened is a series of rapid expansion. All the matter in the universe began expanding, moving outward away from itself and into its current position. So if you look at the data, it is literally showing things being forced and moving outward. It's got your first particles labeled. Here's why I mentioned quarks, because that's what they think may have triggered this. But as these protons, neutrons, electrons of matter, these building blocks of atoms, move out, then you get elements like hydrogen and helium. This ties back to the composition of galaxies and stars. Most stars, the overwhelming majority of them, are big burning balls of hydrogen. So from there, things are still moving outward and expanding. We get atoms, we get matter, stars and galaxies, and the universe expands. Now, we don't know if it expands indefinitely into infinity and just keeps on expanding to where at some point, if humans were even still existing, you looked in the night sky and you saw no stars in it whatsoever because everything had drifted so far apart. However, at that point, I would think the Earth would have moved far enough away from the sun that humans wouldn't be an issue, but nonetheless, you see my point. Things just kept getting farther and farther apart. Some scientists theorize it'll expand so far and then begin to snap together for another singularity here, for a next Big Bang to happen. Some people think that this is a cyclical thing that happens over and over and over. We truly have no clue, and we probably never will. But this is what it means by a period of rapid expansion. So when it talks about stars and galaxies, they are moving farther away from each other. We have some very complicated math that we can do to kind of prove this right now and show evidence for it. So that's why this is a predominant idea. And we don't know if it's ever going to reach a point and snap back together. But this is pretty much the main knowledge you need to have on this. Anything more, and you'll see the questions are very general about this on the test and not super specific because I still don't think they've decided what exactly they're trying to test with the standard. So if this is one that you feel a little uncomfortable with, or you know this is not one of your strong points, this is one of the top standards. I would tell you, don't sweat it and don't stress over, because they're probably, I'd be surprised if there were 3 questions on the whole TNReady test on this, and 3 questions out of the whole entire test shouldn't hurt you, especially when there are other things like the earth science and life science that I know you guys will be awesome on. Don't stress out over this one. It's not worth it. Little tiny bit of review on stars. This is going to be that, again, they are mainly burning balls of hydrogen, almost 3/4 hydrogen. About a quarter is going to be helium, and the remaining 2% is going to be other random elements. Other things that I've seen them ask in the past about stars has to do with their brightness. Now, the brightness can tell you some information about a star. A larger star tends to be brighter than a smaller star, and a hotter star tends to be brighter than a cooler star. So it can tell you a little bit about size and temperature, but other than that, they've not gone very in depth with this standard in the past. And again, just touching base a little bit on the part with galaxies, this second bullet point here, due to the expansion of the universe, scientists believe galaxies are traveling away from each other as the universe continues to expand. That's pretty much the gist of it. Things are drifting apart. And that's pretty much the bulk of the information that you need on this. All right, so here we have one of the first and few questions on this standard from your diagnostic practice test. It says, students are using balloons to describe the expanding universe model. The students blow up several balloons and put them on the floor. Each balloon represents a different galaxy. How should the students move or change the balloons to demonstrate how the universe is expanding? Right there's your big hint. It already says expanding. So again, moving away from each other. So let's look at our answer choices here. All the balloons should be moved to the center of the floor. That does the complete and total opposite of what we said needed to happen. So negative. All the balloons should be moved away from each other so there is more distance between them. Okay, that sounds like the expansion thing we were talking about. Each balloon should be inflated more so they are all increasing in size. Well, If the balloons are galaxies, that would show expansion happening within the galaxies at least. And each balloon should be deflated so there is more distance between the surface of each balloon. Well, then that would show galaxies contracting, but then again, it would also show more space between the galaxies. So they kind of left you with one terrible answer and three answers that sound kind of, sort of doable. So let's look at these in a little more depth. We already ruled out A, so let's check out B, C, and D. B is going to say all the balloons should move away from each other so there is more distance between them. I personally like this answer. However, it is one of the incorrect answers. And if I'm being completely honest with you, if I was just taking this, this is probably the answer I would have picked from first instinct and moved on with it. I believe the downfall of this answer is that it doesn't say what direction they're moved from each other. If it had specified they should have been moved in 360 degrees at the same rate away from each other, then that may have been specific enough, but I believe that's part of the downfall of this answer. Answer choice C, each balloon should be inflated more so they are all increasing in size. Where this one went wrong is that would demonstrate the galaxies are expanding, but the universe itself is not expanding. And the galaxies are expanding, but the universe, that's literally the last part of the question, demonstrate how the universe is expanding. And then D, each balloon should be deflated so there is more distance between the surface of each balloon. This is the correct answer to this test. And this is one I'd want to argue with the test creators on. I don't like this question. I don't think it's a fair question. I think B and D are both very good, very valid answers and easily defendable. And I don't like it. If I'm just being completely honest. But the reason I believe that they chose this one as the correct answer is because it's centering on the distance between the galaxies increasing. Because if you deflate the balloon, it becomes smaller. So that means the gaps between the galaxies are widening. And I guess they're kind of looking at that as a zoom out kind of motion. Instead of where at answer choice B, you would stay zoomed in the same way and everything would just continue to expand and move away. I think they were trying to do more of a perspective look at it with D, where if you took the air out of the balloon and they shrink, there's going to be a greater distance between the galaxies, and it shows that expansion. Not my favorite question, but it is what it is. Moving on to our next question on the topic. It says, evidence gathered by studying the composition and movement of distant galaxies indicates that the universe expanded rapidly from a single small point. The universe has continued to expand for over 13 billion years. Which statement is in agreement with the current understanding of the expanding universe? Our answer choices are: matter and energy came from dark areas of the universe and were attracted to the small point. Okay. Sure. Matter was condensed into a single point until energy was attracted to the matter from dark areas of the universe. Sounds really similar to answer choice A. All matter and energy were contained inside the small point. All three of those answers sound super similar. And last, matter and energy fell into the small point the same way a black hole attracts matter and energy. Yeah, that sounds like the worst answer choice by far, is something falling into a black hole and then being able to escape. That's going to be the answer you can X out. And again, you could sit here and very, very easily overthink and overanalyze answer choices A through C. This is another reason that I don't feel this is a fair standard. I don't know many people my age that could correctly answer this question, nonetheless an 8th grader. So let's break these down and take a peek at them. In the question, it tells you that there was a single small point and the universe expanded from it, which to me would lead you to choose answer choice C. All matter and energy were contained inside the small point. Sadly, that is not the correct answer. Again, not gonna lie, this probably would have been a question that I myself would have missed, because to me, with the information presented in the question and the way that the Big Bang is explained at an 8th grade level, that fits what you're given. The correct answer in this instance is A. It says matter and energy came from dark areas of the universe and were attracted to the small point. The reason why that's going to end up being correct is because that small point was insanely dense. And the more dense something is, and it had a good chunk of mass to it, because that helped create our entire universe. Think about all of the matter in our universe condensed into a single small point. The more mass something has, the more gravitational pull it's going to have. So that's what's going to attract the matter and energy to that small point. And then looking at B, matter was condensed into a single point until energy was attracted to the matter from the dark areas of the universe. We'll go back to the PowerPoint for a second and look at why this is going to be incorrect, because there's just a tiny, tiny little difference between A and B. So to explain the difference between A and B, where A said matter and energy was attracted to the point, B said it was just energy attracted to the point. Why that matter is important is because we have several types of matter in our universe. We have the matter that we're familiar with solids, liquids, and gases. Then we have antimatter and dark matter. Now, when the universe was created, antimatter and dark matter, when they collide, they cancel each other out, and matter ended up winning. For every 1 billion particles of antimatter, there were 1,000,000,001 particles of matter. So some of that antimatter was a part of that attraction. Dark matter is something we're still struggling to explain. We can see it and we can observe it interacting with gravity, and we know there is a lot of it, but that's pretty much the extent of our knowledge. It's super, super limited. So that dark matter, because it is matter, was also drawn in as well. So it wasn't just energy. There is matter in other parts of our universe that we typically don't think of. With all that being said, that is some very specific and specialized background knowledge that you have to correctly answer this question. So if this was one that you did not get correct, similar to the other one, me personally as your teacher, I'm not going to be upset at you for that. If these were 2 questions you missed, that you had picked any of those 3 kind of super similar answer choices, I'm still going to be proud of you for trying and being able to ration through that and justify your answer through a logical argument. So don't take it personally. This is one of those questions that I feel like is purposely made as a trick question or to test students at the very, very, very top levels to kind of see what the highest achieving standards can score on this test. So don't take it personally. It's a pretty rough question. This question hits on 2 standards. It's going to talk about the one that we are currently on, and it's also going to talk about this standard, the one directly under the one that we are currently covering, 8.ESS1.2. Explain the role of gravity in the formation of our sun and planets. Extend this explanation to address gravity's effect on the motion of celestial objects in our solar system and Earth's ocean tides. So let's go back to the question for a sec. It says, the graphic shows the stages in the development of the solar system. Which statement best describes the process of the formation of the solar system? Now, the reason I'm going to tie it to our first standard with the Big Bang is because of the second answer choice, but let's start at the beginning. Magnetism attracted the gas and dust together. How many magnetic gases can you think of? Go ahead, I'll wait. If your home, all the dust in it, think about whenever your mom or your grandma or your aunt, whoever that like super clean freak is in your home, when they start dusting, if they could remove all the dust in their house with a magnet, Do you think they'd have Clorox wipes and Pledge wipes and 5,000 duster thingies and rags? And they'd have a magnet. They'd have a big magnet that they would just everything away with. It's not magnetism. B. An explosion pushed the gas and dust together. Now, with us talking about the Big Bang and it pushing everything out into the universe and it expanding, I don't want you to think that it like all bumped into each other and began forming that way. You need to think about that expansion in 360 degrees in all directions ongoing. So that one is kind of a mean one to put in there, but it was not pushed together with the force of the Big Bang. Also remember, the Big Bang was not a literal explosion. See, gravity pulled the gas and dust together. Like the way that sounds. That sounds very logical and very correct. And the last one, a black hole pulled the gas and dust together. Well, no. Simply put, the middle of a black hole is known as a singularity, and it is so insanely dense that there is no space in that matter. So essentially, a galaxy or a solar system couldn't exist in the way it does today because of all the space within the matter. It doesn't fit our current model. C is the correct answer. Gravity has to do with anything with mass. Well, gas and dust are matter, and all matter has mass. And anything with mass has a gravitational pull, so gravity would pull the matter together. And as the matter grouped together, it increased in mass, which increased its gravitational pull, which pulled even more stuff together to help form galaxies, planets, stars, etc. Our next question says these data tables show the distance of various galaxies from Earth in millions of light years at different times. Which table supports the theory of expansion in the formation of the universe? Now, a reminder, a light year is a measure of distance, okay? Just keep that in mind. So our answer choices are a little scrambled here, but let's take a peek at option 1. So we have galaxy A is 7.84 million light years away from us at 10,000 BC. And then present day, it is 7.99 million light years away from us. Okay, well, we say that our universe is expanding. And it even tells you that in the question, so that matches. It was close to us long ago, and now it's gotten farther away present day. Let's check out B and see if it matches. 10,000 BC, 8.98, present day, 8.9. So it decreased. And that is going to make that answer choice incorrect. So let's check out option 2 then down here. A, 7.84, 7.99. Expansion, 8.98, 9.13. Expansion, 9.5, 9.65. Expansion. And if you do the subtraction, they're each moving away at a rate of 0.15. So they're all expanding away from each other at the same rate. That one seems pretty consistent and solid. Let's check out option 3. So A, 10,000 BC, 7.84, present day, 7.78. Can't have the galaxies moving closer. That rules it out. Let's look at option 4. Galaxy A, 10,000 BC, 8.35 million years ago, present day, 7.99. Again, can't have it moving closer, so that rules that one out. Answer choice is option 2. Now, I know some of you, when you take tests, you're like charts and graphs and stuff, oh my, and kind of freak out. Don't do that, okay? We didn't have to do a lot of complicated math. Actually, honestly, me doing the math was an extra step just to double check that I was right. You really could have eliminated options 1, 3, and 4 just from seeing if they got closer or farther away. So just because you've got charts and graphs, don't let that throw you off or confuse you, okay? Sometimes just a simple remembering what the question's looking for. You're looking for expansion of the universe, so things have to get farther apart, and just an easy, quick back forth check down the list. That's all you need to get this one right. So don't let them get in your head and make you panic. You guys got this. You've worked hard all year. You can do this. And that's all that you have to learn on this topic. Those are all the questions we've got. That's the biggest parts of the PowerPoint you'd need to memorize. So hopefully this cleared some stuff up. I've got some extra videos that we watched in class I can put on my teacher page if you want to watch those that kind of explain the Big Bang in a little more depth, just if you're curious or have an interest in it, because it is kind of some cool stuff they've come up with. But hope that helped you guys, and see you in the next video.